Okay, I don't have a lot of slides. There we go. I am going to recap this for the handful of you who weren't in the earlier session. So New Relic browser, as I talked about before lunch, is measuring page load times in the end user's browser. It uses a little snippet of JavaScript that gets sent down with the page. And when you look at the dashboard in browser, we show the page load timeline in these colors. So we'll show you how much time was spent sending and receiving data to the server in dark brown. Server processing time is purple. Then what we call DOM processing, parsing the HTML, downloading resources, is sort of that tan color. And then page rendering is the light blue. That's actually displaying the page on the user's screen. And as I said in the earlier session, I don't know how accurate it is. Maybe Joel can help me. But I like to think of DOM processing as processing the head section of the page, if you look in the HTML, and page rendering is processing the body section. Is that roughly accurate? Or yeah, okay. Okay. So if you're troubleshooting, if you've got a website whose performance is not where you would like it to be, step one is to look at that chart. I'll bring one up. And say, where is my application spending most of its time? So here is a sample Java application. You can barely see the purple. There's a little tiny bit of purple down there, and you can actually hide elements on the chart by clicking the legend. So if I hide the dark brown and the light brown and the blue, then I can see that my server side app server processing time is like lots of zeros at the beginning. It's pretty fast, right? That's my server. So I've got that running pretty optimally. And then here's my network. Sending and receiving data actually gets me up into the tenths of a second, but still pretty fast overall. Then DOM processing, that's parsing the head section and building the document object model, and memory gets me up to about 0.4 seconds on average. And then we render the page on the screen, which in this case is just another little fraction of time. So overall, my average page load time, you can see the average time up here is about 450 milliseconds, or 0.45 seconds, which is fine. This is not a slow page. But this is just to give you an example of what the chart looks like, the kind of data that you're looking at. If we multiplied this by 20, for example, and the page was really slow, then where would we start? The biggest segment of the chart is DOM processing, that tan color. So then we would want to drill down into the tan section and say, well, what exactly is happening during DOM processing that's causing my page to load slowly? Now, before lunch, those of you who attended that session, I showed you how to do that. Anybody remember? How do you see what's going on during the DOM processing or any of these phases? Anyone? Session traces is the answer. So you can see, oh, should be able to see 5 of them down here. Oh, but not on this account. Let's see. There's some. Okay, so session traces are random samples of individual page loads. So the chart data is aggregated. The finest granularity you can get on the chart is a 1-minute average. So if your site is getting 1,000 requests per minute, then each data point is the average of those 1,000 page loads. Session traces, on the other hand, are not average data. They are individual requests. So at 13:19, which was 4 minutes ago, somebody on Windows running Chrome 34 requested this page, this Pet Clinic Owners 4, and it took 0.286 seconds. And if I wanted to then drill down and say what was going on during each of those phases, during the DOM processing and the page rendering, etc., I could click on the session trace. And again, this was such a fast page load, a total of 0.286 seconds, that it's a very short chart. Usually if you're troubleshooting a performance problem, it's, it takes more time, so the chart will be wider. But we're showing you all of the browser events that fired during that page load. That's what the little blue dots are. And then the individual resources that were loaded, those show up in green. And if they take a while, they're going to be a long horizontal line. So for each individual resource, you can hover and say, how long did jQuery.js take? Less than a millisecond. That's pretty good. But usually it takes longer than that. And then after this light tan color DOM processing comes page rendering. which here is in sort of salmon color. I don't know what color that is. So that's the troubleshooting process. If you've got a page that is taking longer than you would like it to load, you start with the overview and look at the page view load time chart, figure out which phase of the page load is taking the most time, then go to session traces to break into that chunk and figure out on that sort of timeline, it looks almost like a Gantt chart, timeline, what is actually happening, which resources are being downloaded, which ones are taking the most time, what can I do to optimize. Now, I can't really give you specific prescriptive guidance about how to improve the performance of your page because everyone is different. I have one that's having a problem, and you'll get a chance to go in with browser and try to figure out what the problem is. But I did want to give a plug to Clay Smith's talk. When is his talk? Is it this afternoon? Tomorrow at 3. Sorry. Try again. Start from here. There we go. So here's some additional resources. If you're interested in client customer experience, client-side performance, Zeusk, one of our customers, has a talk right after this one at 2 o'clock. Clay has one at 3 tomorrow called Making Browsers Cry. It's my favorite Prince song. Yes? Zeusk is tomorrow. Is it? Okay. Oh, it's you. Okay. Sorry, I got the wrong day. Zeusk is tomorrow at 2? Did I get the time right? Oh, they must have changed the schedule after I wrote the slide. I will fix it right now. Tomorrow at 10:45 a.m. There we go. That is now correct. Okay. And then Clay has that, you ruined my joke though. Making Browsers Cry, which I said is my favorite Prince song. So he's got like the worst website in the world, basically, and he's going to show how to use New Relic browser to figure out what's wrong with it and how to fix it. But in general, if you're looking at a session trace and there are a lot of green bars, a lot of resources being downloaded, each one of those is a round trip to the server, right? So you can speed things up by reducing the number of round trips. Option 2, you can do and or, is if the horizontal green bars are very long, that means resources are taking a long time to download. So then you want to look at a content delivery network or change your caching settings. Clay's going to talk about all that. So that's with the session trace. If you say, during this phase of page rendering, what's happening? And then based on the data that you see, you can figure out, now what do I do to improve it? And then a couple of other resources there. New Relic University is the team that I work for. We've got a bunch of self-paced video trainings that you can take advantage of for free, learn.newrelic.com, and the New Relic Community Forum, which is Holly's team. I'm active there as well. If you have a question that's not answered by one of these other resources, please come there and feel free to ask your questions there or share something that you've learned with the rest of the community. All right, so let's make sure that you all have access to our training account. Here's where things get a little sticky. You should, if you registered for FutureStack before 10:30 this morning, should have received an invitation to the NRU training account. Did anyone see those? Get an email, say, welcome, you, okay. So if you got the email, you can click the link in the email that should take you here directly. If you didn't get an email, but you already have a New Relic account, you can just log into New Relic as you ordinarily would, and then change the URL to look at this account, 1038287. Let me put that up in bigger text. Okay, so when you log into New Relic, it's going to take you to rpm.newrelic.com/accounts/your account number. Just try changing it to 1038287 in the URL. Or the third option is after you've logged in, you'll be on an account like Demotron. It'll have your account name up here, and you can click there and say switch account to NRU training. There we go. That's the one you want. So let me walk around and make sure that everybody can get in there. And Joel, you can help as well. Are we there? Not yet. do you use, can I kill this mic? Can I turn this off or you want to mute it? Yeah, just changed. Oh, I'm back. 1038287. Mm-hmm. Yeah. Okay, so I'm guessing, do you use SSO, single sign-on? You use your, yeah, okay. So I need a I'll say this to everybody. If you use SSO to log in, if you use your corporate credentials to log into New Relic, then we'll need to add a non-corporate email, like a Gmail address or a Hotmail or something. So Joel and we'll come around and get one, and then I'll have to add you. So if you have one, I can do it. Oh, oh, .mail. Okay, got it. Anyone else? Yeah. Oh no, it's a training account, 1038287. So just log into New Relic. You got it. Okay. Anyone else use SSO? Yeah. Okay. Sure. Got it. Thank you. Yes, sir. Yeah, probably. So I need a non-work email. Do you? You want? Oh yeah, that's good enough. Yeah. Thank you. Oh, you're just not connected to the internet. So okay. Yeah. I can't do anything about that. Is there a tech person who can help with Wi-Fi access? Yeah, but they're not able to connect. It's like they're on the Wi-Fi but can't get to the internet. So that I can't help with. Oh yeah, we're probably overloading the hotspot. Okay, well we'll get back to you in a minute. I'm going to add these people. Sorry. All right. Can we show a slide, or do you have a title slide or something so nobody sees me typing everybody's email address? There we go. Thank you. Oh, except I'm also on the FutureStack network. Okay, it let me in finally. 2 more. Oh, and Joel, they need to be, well, I guess they don't need to be admin, but for this. But yeah. Okay, you can, oh, he's back there. You can switch back to my laptop. Thank you. There we go. Yeah. 1038287. Okay, and I'm going to use my phone to get on the internet, so that'll free up one spot for somebody else. All right, so if you're not able to get online, bear with us, we'll try to get that working. But if you do have access to this NRU training account, then you can click the browser menu on the top there next to APM. And you'll see a list of the browser applications that are reporting to this account. And the one we're interested in is this NRU browser demo. So if you select NRU, before you select it, you can see some metrics there. It says the average page load time is 14.1 seconds. That's our problem. We want to bring that down. And then it's telling me I'm getting about 21 pages per minute. And my AJAX calls are taking about 0.387. Also, I've got an 82.3% JavaScript error rate, which is not good. But we'll work on the page load time first, and then we'll see what we can do about the errors. Okay, so if you click on NRU browser demo, it'll take you to that overview dashboard. This one does not, I don't know if it's going to show you the SPA load time. I'm going to switch this in a sec, but just to mention what that is, I talked about it before lunch. We recently rolled out support for single page apps, right? So in the 90s, web applications would ask the server for a page, the server would send back a bunch of HTML and resources, and then when the user clicked on something, it would send that request to the server and they'd get back a whole new page. That's how old style HTML applications worked. Over the years, gradually we have made them feel more like actual standalone or desktop applications by, instead of reloading the whole page, we just send a request for some data. So let's say you're on Grubhub and you want to order some food. So you load the page when you log in, and then when you click on the name of a restaurant, instead of reloading the entire page, it just goes to the server and says, give me the menu items for restaurant 1, 2, 3, 4, 5. And a blob of JSON, JavaScript data comes back, and then it renders that on the page. So those are called single page applications. To the user, it looks like a whole new page came back, but it's really all happening in JavaScript on the client. And we didn't really do very well measuring those types of apps until a few months ago, because we were focused on load time for an entire page. But we recently rolled out support for single page apps. I have one here. There we go. So if when you deploy our JavaScript agent, you say, I want single page app support, then we give you a different, slightly different version of our JavaScript agent in the page that measures not only the initial page load, which is the blue line at the top, but also every time the route changes. The page requests a blob of JavaScript data and renders it on the page. So this is telling me that for my FoodMe app, which is like a simulated online food ordering application, my initial page loads are hovering around for about 500 milliseconds, about half a second, 483 milliseconds. And then every time I request a blob of JavaScript data, those are taking about 0.3 seconds down here. And then if I go to the page views menu, it will actually give me the breakdown of which routes. My wife's Canadian, she hates when I say route. Every time the user requests a different, like a menu for this Beijing Express is pretty fast. Beijing Express is using about 3% of my time, or if I sort this by average response time, Here's Beijing is taking about 0.296 seconds. These are different servers. That's why they're broken out separately. You can see the URL is coming from a different web server. This is my favorite, non sequitur Indian restaurant. Somebody got to make up these fake restaurants. I didn't do it. People blame me, but it's not me. Checkpoint, how about checkpoint? That's another one. So this is single page app support, is breaking out page loads or page response times by the full page and also by the route changes. And this is filterable and facetable, I guess you could say. You could group them by browser interaction name or by user agent. Are certain browsers slower than others? Are people coming from certain cities taking more time than other cities, etc. What we're interested in is our NRU browser demo, which we don't want SPA. It is not a single page app. And your assignment is to look at this data, this chart and the session traces, and figure out why is it blue? Why is it's taking 14 seconds to load. Come up with a theory as to why that is. So we'll give you a few minutes. Does everybody have access to this now? Do we have anybody who can't get in? Couple? Okay, I'll come back and help you. But everyone else, log in, look at the data, see if you can figure out what's wrong with it. While you're doing that, I'm going to deploy the fixed version. There we go. So from this point on now, it will be faster. But see if you can figure out what I did to make that happen. And let's come back and get everybody online. Able to log in, or are we good? So let's see. Oh, well, I'm back. Let's go to your network settings. That. And then adapter. Change adapter settings. The wireless. The V4 one there. Yep, properties. And then use a specific DNS, 208.67.200. Oh, sorry, you got to do an arrow to 67. Right arrow, or click, yeah, 220, 220. Try that, yeah. Okay, and close. I think Google 8.8.8.8 will also work. Don't they have a Google DNS? Oh, yeah, it might be okay. So now you got to log out. Did I set one up for you with a personal? Oh, so I need that as well. Can you maybe write it down? A non-corporate email address. Okay, and did we fix your DNS? Let me see if I can help you. Thank you. Properties. Try that. Configure. No, that's not it. Sorry, that's the driver. We want the wireless properties. No, sorry. I'll get there. That's not what I want to see. Oh, you're bridged. What do you bridge to here? Yeah, it's not connected now, so we have to tell it which. So if you look at the chart, you can see that I deployed my fix, and look at my response time has dropped way down. So it worked, whatever it was. So oh, sorry, maybe just follow along, and I can't help you. Change her DNS settings. Okay. So anybody have a theory? What did we do from here? We noticed that we're getting slow page load, 14-second average response time. What's the first question you want to answer? What's making it slow? Okay, that's good. Anything more specific? Looking at this chart. Okay, and so that's a little too specific. Somewhere in between those two, we want to know which phase or which part of the page load process is taking the most time, so that we can then find the asset or the error. So in this case, looking at this chart, it's not network time. Network time you can barely see. It's a tiny little brown blob at the bottom. DOM processing is about 1.5 seconds, but that's not it. It was clearly in the page rendering phase, right? The blue section of the chart. So now we know which part of page loading. And remember, page rendering is processing the body section of the page. DOM processing is the head. So now we want to look at what's happening in the body of the page that's taking 12 seconds or so. So how do we see what's going on then during that blue part of the chart? Step 2. Session trace. Good. Very good. So there's a couple ways to get to them. If you just scroll down on the overview page, the 5 most recent session traces show up here. And there's been, I don't know if they fixed it. Do you still need to click on the little /? Oh, he doesn't know. Let's find out. I would always try to click in this whole horizontal bar area and nothing happens. Anybody hit that? So you have to click on the actual part of the URL. You see it? In this case, it's just the /, so it's like a dexterity test. Do you have enough eye-hand coordination to hit that little slash? So that will take you to your session trace. So you can pick one of these. That's one way to get to them. The other way is to go to the session traces menu. Now in our example, that's not super useful because there's only one page. But if you have a real world site with lots of different pages, the session traces menu allows you to filter this list by typing a part of the URL. So up there where it says search recent traces, if you're interested in a specific page and you want to see, do I have any session traces for that page, you can start typing part of the URL up there and see that detail. I showed this earlier in the before lunch session. I was looking at data for the New Relic blog. And when I looked at session traces, now these are all different blog articles, right? But maybe I'm interested in one particular article. So I used one called Popular Programming Languages 2016. And I've only got one session trace in the last 30 minutes. So let me zoom out and pick a longer time window. There we go. So these are now all traces for the same page. And the reason I do this is to make the point that look at the page load times over there on the right. For the same page, here it took 1.6 seconds. Right below that, like how many minutes earlier? Or 13 minutes earlier than that, it took almost 5 seconds. Here it took 11 seconds. Here it took almost 33 seconds, right? So why is the same page taking such a wide range of load times? Those of you who were in my before lunch session know the answer to that. Anybody else have a theory? Why would the same page take a really long time and then a second and a half? Could be traffic. Could be we're measuring this on the end user's machine, right? We've got a little snippet of JavaScript running on their phone or their desktop. So it depends how fast their internet connection is and how fast their computer is and what other work they're doing on the machine. So there are a lot of variables that can affect the load time, and we'll talk about how synthetics can help you with that a little bit further on. So pick a session trace. I'll pick one. I got to pick one of the slower ones now, right? Where it was still before I deployed the fix, 14.5 seconds. And the session trace then gives you the breakdown of how much time was spent server-side processing, how much time was spent parsing the HTML, the DOM, and then finally rendering the page. And clearly, that's where the bulk of our time is being spent, about 13.5 seconds in this example. So now we can scroll down and look at the chart, the session trace chart, and you can see I've got a few resources here in the DOM processing section, CSS, JavaScript, a couple of images. Page rendering, here's the color. You guys see that color? But look, nothing's happening. It's just a big gap of emptiness. But right before page rendering started, anybody notice anything interesting? Hint, hint. It's all those iframes. So actually, if you're looking at a session trace, the URL is up here, and you can actually click that and view the page. So here's the page that I'm timing. When I needed to develop browser training, New Relic browser training, I said, I need a really bad page, a poorly performing page, but obviously I can't show a customer's page. Hey, look at our customer's page that performs poorly. So I had to come up with one. And it turned out our old New Relic University site was a bad page. So here's what it used to look like. It's got a bunch of tabs on the left-hand side. And when you choose a tab, on the right-hand side, there are a bunch of iframes with videos in them. See that? So we're hosting our videos on a third-party site called Wistia. Oh, I hear it playing. I hear my voice. Okay. There we go. It was coming out through the HDMI. So there's a bunch of iframes. How many tabs do we have here? 8 tabs. On each tab, we've got 4 to 6 videos. Every one of them has an iframe in it with a video. So when this page loads, you could see all those iframes on the session trace. It's going out to our video hosting provider and grabbing all of those videos to populate the iframes. Why do you think that the page rendering section is empty? Got to do a little detective work here. Anybody have a theory? There is some waiting time. If you think about what are we measuring here? What is New Relic browser measuring? The end user load time for the container, right? The page that we see in our browser. It's like the skeleton or the framework of the page. But then an iframe, what gets loaded into an iframe? Another page, right? An iframe has a source attribute that points to a completely different URL. So browser, New Relic browser using its JavaScript agent is not going to dive into the iframe and measure how long that other page takes to load, right? So these are iframes with videos in them, and you can see that if you hover over one of them. fast.wistia.net, embed, iframe, and then an ID. So the container itself took 65 milliseconds to load, but then there's a source attribute that goes out to Wistia and downloads a video. And browser product is not measuring the time that it takes to download the video because that's a separate page. Browser says, you told me to measure this page, not the one that's inside that iframe. So that's what's happening during all this dead air, is all those iframes are downloading the videos to display on the page. Does that make sense? So we could, and in fact I did, improve the load time by, instead of preloading all of these videos, what would you do? How could you improve that? If you look at the page itself, you got tabs, and within each tab we've got these little collapsible regions. We could lazy load the video. We could wait, for example, until the user clicks the APM tab and then just go get those 4. Or we could wait until they click transaction and error traces and then go fetch the video right then. So we can load them as needed rather than preloading them all as the page is rendering. And that, in fact, is what I did. I changed the way this page works so that it doesn't actually get the iframes until the user clicks on one of the tabs. And what did it do to our timing? That looks better, right? So here's what it was doing before when it was fetching all of the videos during the page load. Now it doesn't fetch any videos until the user clicks on a tab, so that video fetching time is not getting counted as part of the page load timing. The page loads and then the timer stops before the user clicks on any of the tabs. And now we're down to less than 2 seconds. I got a little spike there up to 5 seconds. But it looks like in general it's below 2-second page loads. So by lazy loading, instead of preloading everything during the page load, we can reduce that page load time. And that's a contrived example. I wanted it to be obvious and easy to fix. But in realistic terms, for example, if a lot of particularly less experienced jQuery or JavaScript developers put a whole bunch of code in the window load event, it's like, okay, I'm gonna go get the page, download all the images, and then when that's all ready, this window load event's gonna fire and it'll execute my code. And we count the window load event as part of the page load timing. So if you've got a bunch of stuff happening in onload or window load event, that's going to balloon your page load. So if you ever visit a New Relic page, you'll see stuff like this. Watch for the spinners there. See the spinners? So the page loaded, and then after we stop the page load timing, then we asynchronously go out and fetch the data that we need to render those charts. So you could argue whether that is better because the user still can't really do anything until the charts are there, but it makes our numbers better, and that's what counts. No, I'm kidding. I'm kidding. We really want the experience to be good for the user, but that's one option, is to defer data that they may not need right away. We can make the page interactive and go fetch the data in the background. So did anybody come to that conclusion, or did I have to just give away the answer? Yeah, okay, well that's fine. Now you know, right? You can go back to work and say, that browser chart looks like things are taking a long time. And the troubleshooting process is start with the overview, figure out which phase of the page load is taking the most time, and then use session traces to dig in to that, to the timeline, and see, is there a resource that's really slow? Are there too many resources that are taking a long time? In our case, it was preloading a bunch of fat videos with an FAT, not a PHAT. If they were fat with a PH, that would be good. That were causing our pages to take a long time. Now let's see how we could use synthetics. I'm just trying to keep you awake. It's after lunch. How we could use synthetics to enhance the data that we're getting from browser. So over, if I go to synthetics, I am using synthetics to monitor that same page, the NRU browser demo page. One thing that we can do in synthetics is normalize the data, right? So if browser is telling us that the same page takes 2 seconds and 30 seconds, synthetics, because it's a controlled environment, it's not the end user's machine out in the Wild West, but it's a machine that's only visiting our page. It's got a fast internet connection. This tells us what reality is. Well, this is telling me reality. In reality, your page is taking like 15 seconds to load. But if I look at one of the results of this synthetic check, results menu, now see, my most recent ones are fast because I deployed a new version of the code. But let me sort by slowest. Duration descending. And boy, 45 seconds is a little too slow. I'll pick one of these. It took 32.7 seconds in San Francisco. Synthetics gives me something that looks very much like a session trace. It shows me each of the resources, the web page itself, stuff from the head section of the page like JavaScript and CSS files. It marks the DOM content loaded event and the page loaded event. So this vertical magenta bar is when my DOM processing phase completed at about 1.67 seconds. And then you could see there was a long period of time between DOM content loaded and when the page finished. Synthetics will actually let me see, instead of just blank space like browser, I can actually see what was going on during that time. So if I scroll down, do I have any long? I was looking for long bars, but I don't have any long bars. But I can see these little thumbnails? If you can see them. Well, I zoomed in and now the thumbnails went away. Anyway, they were thumbnails of a video that I can't show you if I zoom in, so I'll zoom back out. Oh, sort by duration, yeah. That'll put the slowest ones at the top. There you go. Okay, so these are a couple of web fonts that were the absolute slowest. But here's, oh, that's SurveyMonkey. Here we go. So these URLs are fast.wistia. That's an embedded video right there. fast.wistia.net, blah, 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 a bunch of gibberish. And we can see, it wasn't very big, 9.34K. But it did take 266 milliseconds to load. So, well, I wanted to show the timeline just to show that instead of getting blank space during page rendering, because synthetics is not using the resource timing API that browser uses, but it's actually using a Google Chrome specific API. It's kind of like what you see if you're in Chrome and you open developer tools. Have you ever done that? Open dev tools in Chrome, visit a page and go to the network tab, and it'll show you all of the resources that were downloaded. So we're getting that same kind of information, except instead of just getting it on your local desktop, now you can get it from machines around the world on a schedule. And then we can show you, okay, here's this is the thumbnail image for the video. And you can actually view resource. There it is. That's the thumbnail of the video. And then the video itself will be one of these other, probably this data. No, that's a font. Well, somewhere in here, it actually downloads the video itself. So you can use synthetics with browser to say, all right, if there's something that browser can't show me, like an iframe loading, synthetics may be able to show me what's going on there. Synthetics will also allow me to take variables out of the equation. So I'm not getting slow loads because of my end user's slow machine. I was going to say the last nice thing, but there's more. So another nice thing about synthetics is that you can choose what gets monitored, right? In browser, you only get page load data from pages that your user visits. So there may be some problem on your site and you're not noticing it because nobody's actually followed that code path. And you don't want your customers to be the ones who discover problems. Like our customer from TrueCar said this morning, he's like, a lot of times before they started proactively monitoring, the customer would call them and say, your site has a bug. That's not a great customer experience. But with synthetics, you can make sure that everything you care about is being proactively monitored, either by visiting a URL or by scripting a browser, which I'm going to talk about at 3:15. You can automate a browser to simulate user behavior. And then the last nice thing that I'll mention is that synthetics is feeding all of its data up into New Relic Insights. So if I go to Insights, if I'm looking at browser data, it's going to show me information about one particular application that I'm monitoring. Synthetics, however, is feeding all of the data from everything on your account into this big data store. So I could say now, for example, show me the average duration is load time, from synthetic request events. So on that timeline chart, every row, every resource is a synthetic request. The HTML page, the CSS file, file number 1, JavaScript file number 2, JPEG, a PNG. Every one of those is a request, and we capture what the resource URL was, how long it took to load, lots of information about each of those. So I could say, show me the average load time for synthetic requests across my account since 1 day ago. So the average load time across my entire account is 112, are those seconds or milliseconds? Milliseconds, 112 milliseconds. Now I want to say, well, what are the slowest URLs? So I could facet by URL. Oh, missed. And now I'm hitting the power button. I don't want that either. Okay, so now it's going to take these synthetic requests and group them by URL and show me the slowest average response time. There we go. So this Facebook like button has an average of 425. That's average, right? Now, what if instead of average, I say maximum? Oh, max, not maximum. There we go. Ah, here's my slow step. So something from Wistia took 15.7 seconds, and a SurveyMonkey, whatever that is, took 11.3 seconds. So this is now across all of the sites that I'm monitoring. Maybe I want to get more specific and say, what are my slowest loading images? Not just all URLs, but I could say where content category equals images. And now this shows me just, that's a JPEG, took 8.2 seconds. This is a Twitter something or other, I can't see what it is. So these are just images, JPEGs, PNGs, etc. So synthetics feeds all that data up to Insights where you can slice and dice across your entire account, not just one application. And I am now out of time. Any questions about anything we've covered today? No? Well, I'll hang around for a few minutes. If you have questions, I'm happy to answer them. I'm back at 3:15 to teach how to write synthetics monitor scripts, and check out Clay Smith's talk tomorrow afternoon where he's going to talk about if your site is slow, here's how you can fix it.
Thank you, Phil. Round of applause for Phil.